Hello everybody, welcome to this video. In this video, we are going to discuss about how does sound travel. The propagation of sound we are going to discuss. In order to propagate, sound requires a medium through which it can travel. This medium could be a gas, liquid or solid. Sound propagates in a medium as the particles of the medium vibrate from a starting point. This means that sound always has a starting point and an ending point. For this instance, while you talk to a friend, as you speak, the particles in the air get displaced due to the pressure caused by the sound you produce. Then they displace the adjacent particles and so on. In this way, sound travels from your place to your friend's ears. Therefore, we can say that the particles of a medium do not travel from one point one another in order to propagate sound. Sound propagates because of the disturbance caused by the source of sound in the medium. What is a wave? A wave is a disturbance produced in a medium as the particles of the medium vibrate. The particles produce motion in each other without moving forward or backwards. This leads to the propagation of sound. Hence, sound is often called a wave. How can sound travel through air? When an object vibrates in the air or produces a sound, some regions of high pressure are created in front of it. These are called the regions of compression. These regions of compression move forward in the medium as particles exert pressure on their adjacent particles. Adjacent particles is nothing but the next particle. With the alternate regions of a compression, there are also regions of low pressure that are in its front. These are called regions of rarefaction. As the object would move forward and backwards, continuously producing sound, the series of compressions and rarefactions will be created. This will allow sound to move through air or any other medium as well. If the medium is dense, the pressure exerted on the particles will be more in order to propagate sound and vice versa. Therefore, we can also say that propagation of sound is all about change in the pressure of the medium. What are mechanical waves? A wave that is produced when objects of the medium oscillate is called mechanical wave. The sound waves are therefore mechanical waves. The waves can be classified into two different categories. The first one is electromagnetic waves. Second one is mechanical waves. The electromagnetic waves consist of transverse waves, that is light wave, X-rays, infrared and ultraviolet rays. In mechanical waves, we have two different categories. The first one is transverse waves. For example, water ripples. And the second one is longitudinal waves. For example, sound waves. Sound cannot travel through the vacuum as it always needs a medium to propagate. This vacuum contains no air, hence no particles can propagate sound. Longitudinal waves. Any wave that vibrates in the direction of the motion is called longitudinal wave. Sound wave are called longitudinal wave because the particles of the medium vibrate in the direction which is parallel to the direction of the propagation of the sound waves. The particles in the medium oscillate to and fro in the case of longitudinal wave. Transverse waves. A transverse wave is produced when the particles of the medium oscillate in the direction which is perpendicular to the direction of the propagation of the wave. The particles in the transverse wave oscillate in an up and down motion. For example, light waves are transverse in nature. Compression. Compression region is represented by the upper part of the wave curve. It is a region where particles cluster together. The density as well as pressure is always high in this region. Rarefaction. A rarefaction is represented by the lower part of the curve. It is a region where the particles separate out. Rarefaction region always has lower pressure. Crest. It is the peak of the curve. Trough. It is the crest of the curve. Wavelength. The distance between two consecutive compressions or rarefactions is called wavelength. SI unit of wavelength is meter. Frequency. The number of oscillations per unit time is called the frequency of a wave. The number of compressions plus number of rarefactions per unit time. The SI unit of frequency is Hertz. Hz. Time period. The time taken between two consecutive compressions or rarefactions to cross a fixed point is called time period of the wave. In other words, the time taken for one complete oscillation through a medium is called a time period. That can be denoted with a letter capital T. The SI unit of time period is second.